Hello friends, how are you? I hope you all are well. In my last video, I explained about dimensional formula and dimensions. Today's concept is principle of homogeneity of dimensions. Dimensional formula means what I said? I said the formula in the form of fundamental quantities, that is the dimensional formula. Dimensions, I said, the powers of the fundamental quantities of a dimensional formula are called dimensions. Like this I said. What I said? Suppose velocity is said. Velocity means displacement upon time. Displacement, I use the length. Time I use t, that means L t to the power minus 1 or m to the power 0, L to the power 1, t to the power minus 1. This is the dimensional formula. I explained last class, just I reminding. Dimensional formula and 0, 1, minus 1. This is dimensions. Okay, last video I explained. Today's concept regarding principle of homogeneity of dimensions. What is principle of homogeneity? Let us see. For example, 5 mangoes. 5 mangoes. I can't add with 2 grapes. It is not possible because they are not of the similar quantities. They are different physical quantities. See here. 2 liter milk plus 5 kg sugar. I can't add it. The fact is that liter correspond to volume, kg correspond to mass. So volume and mass are not the similar quantities. Here mangoes and grapes are not the similar things. So we can add those physical quantities. Those are similar types. Those are same kinds. That means I can say that the physical quantities, those have similar dimensions or dimensional formula. We can add, subtract or equate. The physical quantities, I can write that the physical quantities with similar dimensional formula or dimensions can be added, subtracted or equated. That means if both have the similar quantities, their dimensional formula same, their dimensions same, then we can add, subtract or equate. Okay, so I can say that the principle of homogeneity states that principle of homogeneity states that, what states that? Similar physical quantities, similar physical quantities can be added, subtracted, or equated. Second point is that the dimensional formula of LHS and RHS of an equation should be equal. Okay. Similar physical quantities can be added, subtracted, or equated. We can add, subtract, or equate. Dimensional formula of a left hand side and right hand side of an equation should be equal. Let us see an example. It will be give you more clear picture about the homogeneity. So the best simple example I am giving. Okay. So consider v square minus u square equal to 2as. Here v means final velocity. Okay. U stands for initial velocity. A for acceleration. S for displacement. Okay. Now let us see the LHS. LHS. Okay. That means dimensional formula of LHS. Okay. Left side what is given? Square of the final velocity minus square of the initial velocity. So velocity what I can write? Velocity is equal to displacement upon time. Okay. So I can write dimensional formula of velocity is equal to displacement means length L time t. That means L to the power 1 t to the minus 1. I can write m to the power 0 L to the 1 t to the power minus 1. Okay. Dimensional formula of a velocity. You see that it is given square of the velocity. So and v square u square both are the similar physical quantities. So dimensional formula of v square equal to m to the 0 L to the 1 t to the minus 1 square is equal to m to the power 0 L to the power 2 t to the power minus 2. Okay, so it is a formality to write the NLT, or I can write L to the power 2 t to the power minus 2, no matter. Okay, so dimensional formula dimensional formula of left hand side is equal to m to the power 0 L to the power 2 t to the power minus 2. Clear? What about the RHS? You see that dimensional formula of RHS. Right hand side what is given? 2as acceleration. So acceleration is equal to change in velocity upon time. So velocity what we got? Velocity L t to the minus 1 divided by t is equal to L t to the power minus 2. Okay, or I can write m to the power 0 L t to the power minus 2. This is acceleration. So the dimensional formula of acceleration. Okay, we got this one. Next one, here s is the displacement, so I can write dimensional formula of 2as. Okay, or right side RHS means 2as. 2 is the number, so your acceleration is m to the power 0 L t to the minus 2 into displacement L is equal to m to the power 0 L to the 1 t to the minus 2. Okay, that means what we got? We get LHS, we got RHS. So I can say that dimensional formula of LHS is equal to dimensional formula of RHS. So today in this video I explained about the principle of homogeneity of dimensions. That means if both are the similar physical quantities or the dimensional formula dimensions are equal, then we can add, subtract or equate. So in my next video I will explain some important points, especially about the applications of dimensions and dimensional formula, especially in our day-to-day life, to solve many problems in physics. Until then, bye.